Lesson 7.2 is going to be about graphing polynomial functions. Now, whenever we graph them, we want to know a couple things first. So, if we are looking at graphing this function, negative x cubed, or should I say f of x, is negative x cubed minus 4x squared plus 5. Well, first thing we want to know is the degree. This will tell us a lot about our function. Now we can see that the highest polynomial, or the highest power of x is 3. Then the leading coefficient, or LC, the one that's in front of it here, is negative 1. All right, so that helps us with a lot of stuff. Now that we know that it's degree of 3, well, 3 is odd, so that tells us a lot. 3 means it's a cubic function, so we know that it'll kind of give this curved look here, or it might start at the bottom and give this curved look here. We're not really sure, but we know that it's cubic. But we know that the leading coefficient is negative 1. And from our properties of functions before, given the degree and the leading coefficient, if it's negative, that means we know that as as x approaches negative infinity, then f of x will approach positive infinity. So it's going to start from the top, coming downward, and then in the end, it should end as x approaches positive infinity, f of x will approach negative infinity. So it should end up looking like this. As well, we can make a note here that at most there are 3, oops, that's a 3, zeros. So we know a fair amount about this function already. Now, if we want, we can also plug in or find the y-intercept. Remember, y-intercept is just when x is 0. So all we could do is just call this 0 and call this 0. So our y-intercept is 5. So that was actually pretty nice and easy, pretty quick to find that, that y-intercept. Before we can graph it, though, now we're going to need to make a table. Now, normally I would show you on a calculator on screen, but my free trial is up, actually, so I don't have the software for that. So what you're going to have to do is, on your graphing calculator, plug in this equation into your y equals and find the table. I'm just going to go through and plot out the points that I got on my calculator on screen here. When my x was negative 4, my y was 5. My x was negative 3, and I had negative 4, negative 2, negative 3, and so on. I'm just going to go through a bunch of these. So these were some of the points that I was able to find. So now I just plot these out. When I'm at negative 4, I'm at 1, 2, 3, 4, 5. Negative 3, negative 1, 2, 3, 4. Negative 2, negative 3. Negative 1, 2. 0, 5. 1, 0. Negative 2, 19 is way down here. So it looks like our line is looking something like this. We know that's coming from way up here, getting all the way down, coming up, hitting these points, and then coming right back down. So this is how our graph is going to end up looking. Again, you're going to want to use a graphing calculator to plug in your function and get that table of values. So in this case, we want to locate the zeros of a function. Remember, zeros it's the same as saying the x-intercepts. So we want to know the x-intercepts of our function. So we need to determine consecutive values of x between which each real zero of the function f of x equals x to the 4th minus x cubed minus 4x squared plus 1 is located. Then draw the graph. Actually, I think it would probably be easiest to draw the graph first, and then we'll find exactly where all of those are. So again, we'll start by asking, what is the degree of the function? Well, our biggest value, or our biggest power, is 4, which tells us a lot. It tells us it is even, and it's quartic, 4, So it's going to look something like this or something like this. We're not 100% sure yet, but we know that the leading coefficient, so the one out in front, is 1. It's just x to the 4th power. Since it is positive, we know that it's going to be this version. It's going to start as f of x approaches, or as x approaches negative infinity, f of x will approach positive infinity, and as f of x approaches positive infinity, f of x will approach positive infinity. So it'll go up at the ends of both. So we know it's going to look something like this. Now again, we just have to make our xy table. Again, you should use your graphing calculator to plug in this function and find a table. I will just give you the points that I found. So when I had -2, -1, 0, 1, 2, and 3 as some of my points. Then I had 9, -1, 1, -3, -7, and 19. So it looks like we're not going to be able to fit everything on the graph here. Already, -2, 9 is something like that, way up there. -1, -1, 0, 1, 1, -3, 2, -7, 1, 2, 3, 4, 5, 6, 7, and 3, 19 is way up there. Looks something like that. So, looks like it'll look something like this. So this is how our graph is going to look, something like, and we need to find the zeros, or at least find consecutive values of x that they're going to be in between. So it looks like it's going to happen here, 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 and here. So we'd say that our zeros, the x values that they're in between, it looks like it's in between -2 and -1. That would be this one here. Between -1 and 0. Between 0 and 1. And between 2 and 3. So we'd actually want to say, we'd probably have to say for each one, zeros between -2 and -1, between -1 and 0, between 0 and 1, between 2 and 3. So that's where all of our zeros would be. That's how we'd solve that one. All right, in this case, we're looking for maximum and minimum points. More importantly, we're looking for what are known as relative maximum and relative minimum. Now, what that means is you don't have to be the highest point in the whole graph. You just have to be the highest point in your area to be your relative maximum. And you don't have to be the lowest point on the whole graph, just the lowest in your area to be the relative minimum. That's how those work out. So to find these relative max and relative min, we need to graph the function. So we'll look at what is the degree of the function. Well, it's f of x equals x cubed minus 4x squared plus 5. So our highest degree is 3. It's cubed there, which means we know that it's an odd function. And it's either going to look like this, or it's going to look something like this. The way to determine which one it is, we have to look at the leading coefficient, which is +1. Since we know it's positive, then we know that it's going to start going down and end up going up. So it's not going to be this one. Start going down, end up going up. So we know how it's going to look, at least somewhat. Now we need to find how the actual graph is going to look, so we make our XY chart. Again, you should be plugging these values into your calculator on your own, or should plug in this function and then finding a table on your own. Here are the values that I found. If we're looking just at our x values over here, I'll only go that far, and then for y, there we are. Give us a little more room. So at where x is -2, we're at 19, so it's, oops, -19. So we're somewhere way down here. At where x is -1, we're at 0. Where x is 0, we're at 5. 1, we're at 2. 2, we're at -3. 3, we're at -4. And 4, we're back up at 5. So that means we're going to be looking something like this. Here's our graph. So to find the relative maximum and relative minimum, again, if we pick a point like that, that's neither the relative max nor the relative min, because there are points that are lower than it, there are points that are higher than it in its area. But if we look at a point like right here, we would call that a relative maximum, because in its area there are no other points higher than it. So there we have a relative maximum. Here we have a relative minimum. There are no other points lower than this at this in this area. So we would say then our relative max occurs at 0, 5. Our relative min occurs at 3, -4. The question was, find the x-coordinates at which they occur. So you would say then x-coordinate of relative max is 0. And the x-coordinate of relative min is at 3. So those are our values that we're searching for. And that's lesson 7-2.